Hello everyone, welcome to National Standard Examination in Junior Science 2014 Physics Solutions. Three identical vessels carrying equal amount of water are placed in three lifts. Lift A is accelerating upward, lift B is accelerating downward, while lift C is moving up with constant velocity. The pressure at a depth h from the free surface in three vessels is measured as PA, PB and PC, then which of the following is true? Pressure in a static liquid is given by P equal to P naught plus rho gh. So pressure in a static liquid for vertically accelerated vessel is given by P equal to P naught plus rho g effective into h. So G effective is G plus A. In the second case it is G minus A. In the third case it is equal to G. So PA is greater than PC is greater than PB. A particle starting from rest is moving with uniform acceleration in a straight line. The percentage increase in displacement of the particle in the 9th second compared to that in the immediate previous second is about. Displacement of the particle in nth second is given by Sn equal to u plus a into n minus half. So displacement in 8th second will be 7.5 a and displacement in 9th second will be 8.5 a. So the increase in displacement is 8.5 a minus 7.5 a, that is a. The percentage increase in displacement delta s by s into 100 comes out to be 13.3%. An inflated balloon with a heavy rock tied to it submerges in water. As the balloon sinks deeper and deeper, the buoyant force acting on it. Gravitational force, that is nothing but weight of the object, is constant in magnitude and direction. It always acts vertically downwards. Buoyancy force, weight of displaced liquid, which can be given by V rho g, where V is volume of the liquid displaced, rho is density of the liquid and g is acceleration due to gravity. As the balloon sinks deeper and deeper, the pressure of water on the balloon increases, because of which the volume of the balloon decreases. As the volume of the balloon decreases, the buoyancy force acting on it decreases. A particle is moving along a straight line. Its velocity time graph is as shown in figure. Then match the following. Take your time to go through the velocity time graph. Given velocity time graph is a straight line, so its slope is constant and negative. The straight line crosses the time axis at t equal to 4 seconds. So the velocity of the particle at t equal to 4 seconds is 0. The slope of velocity time graph gives acceleration as it is negative. At t equal to 2 seconds, the velocity of the particle is decreasing but moving in the same direction. So option B is correct. A rectangular parallelepiped with sides A, B and C in the ratio 3:2:1 is kept on a uniformly rough horizontal surface as shown in figure. The value of limiting friction is. Limiting friction is nothing but the maximum value of static friction. It is independent of area of contact. So, same amount of frictional force will act in all the three cases. If two bodies of different masses initially at rest are acted upon by same force for the same time, then both bodies will acquire the same. Given force acting on both the masses is same, so F1 equal to F2, initially both of them are at rest. Force acts on the bodies for the same time, so the acceleration of the object A equal to F by m. So A1 equal to F by m1, A2 equal to F by m2. Velocity after some time V equal to u plus at, that is at, since the bodies are initially at rest. Force acting on the body can also be written as F equal to dp by dt, where dp is change in momentum. So from there change in momentum is F dt. As the same force is acting on both the objects for the same time, the change in momentum is same for both cases. As the objects are initially at rest, they will acquire same final momentum. It is more difficult to walk on a sandy road than on a concrete road. The most appropriate reason for this is, let us define friction here. It is a tangential force that opposes the relative motion of a point of contact between two surfaces. As we walk, we push the floor backwards, so the frictional force acts in the forward direction, helping us to walk. The frictional force between the sand and feet is far less than the frictional force between concrete and feet. So it is relatively difficult to walk on sandy road than on a concrete road. The magnetic force on a moving charged particle can change the particles. The force acting on a charged particle due to magnetic field is given by F bar equal to Q times V bar cross B bar, where Q is the charge, V is the speed and B is magnetic field strength. The magnitude of force can be written as F equal to QVB sin theta. The direction of the force is perpendicular to the plane containing the two vectors, as it is cross product. So work done by the centripetal force is 0. So the force changes only the direction of motion of the particle. A ray of light is incident on a system of mirrors as shown in figure. What is the total deflection D of the ray when it emerges out after two reflections? Angle between the mirrors is 70 degrees. So the angle of incidence at N1 is 20. Angle of incidence equal to angle of reflection. So angle of reflection is also 20 degrees. Angle of incidence at N2 is 50 degrees as the angle between the two mirrors is 70. Again, angle of incidence equal to angle of reflection. So angle of reflection will be 50. From the diagram, sum of the angles in a triangle is 180. So the angle of deviation D equal to 140 degrees. A light source of diameter 2 cm is placed 20 cm behind a circular opaque disc of diameter 4 cm. Shadow is formed on a screen at a distance of 80 cm. The ratio of area of umbra and penumbra shadow regions is equal to. I suggest the students to pause the video for some time and go through the diagram carefully. If possible, draw it on your own because it involves a lot of angles and the geometry principles. See the solution in the next slide. AA dash is the source, that is disc of radius 1 meter, and BB dash is the opaque disc of radius 2 meter. Umbra is formed between ABC and A dash, B dash and C dash. Penumbra is formed between CD and C dash, D dash. Light rays from the source are extended to meet at point O. Triangles OFA and OEB are similar triangles. So we can take OF by OE equal to FA by EB. We get x equal to 20 cm. Triangles OFA and OHC are similar triangles. OF by OG equal to FA by HG, from where we get R equal to 6 cm. Triangles FA-G, GBE are similar triangles. FG by GE equal to FA by EB, from where we get Y equal to 20 by 3 cm. Triangles GEB and GHD are similar triangles. GE by GH equal to EB by HD, from where we get capital R equal to 14 cm. Area of the umbra region pi r square, that is 36 pi. Area of the penumbra region pi times r square minus small square, which comes out to be 160 pi. So the ratio of area of umbra to penumbra is 0.22. Consider the following two statements. Statement 1. When red light travels from air to water, for observer in water it appears to be still red. Statement 2. Color of light is associated with frequency and frequency does not change when light travels from one medium to another medium. Choose the correct options. Coming to statement 1, color of light does not change as it travels from one medium to another medium. Statement 2, as light travels from one medium to another medium, its frequency remains constant because frequency depends on source and color depends on frequency. So statement B is correct. A spring of force constant 7600 Newton per meter is attached to a block of mass 0.25 kg as shown in figure. Frequency of oscillation on a frictionless surface is. Frequency of oscillation of a spring block system F equal to 1 by 2 pi root k by m. Upon substituting the numerical values, we get F equal to 27.76 Hz. A wave is sent along a string by oscillating at one end. If the tension in the string is increased, then the speed of the wave and wavelength of the wave. Transverse waves travel along the string. Speed of transverse waves is given by the formula V equal to root T by mu, where T is tension in the string and mu is linear density. From the formula we can write V is directly proportional to square root of T, as linear density remains constant. As the tension in the string is increased, so the speed of transverse waves also increases. Speed of wave in any medium in terms of wave parameters is given by V equal to F lambda, where F is frequency and lambda is wavelength. Frequency of the wave depends on the source, so it remains constant as long as the source does not change, from which we get V is proportional to lambda. So the wavelength increases as the speed of the wave increases. Clock A based on oscillations of a spring and clock B is based on pendulum motion. Both the clocks keep the same time on Earth if they are taken to a planet having half the density of the Earth and twice the radius. Time period of a spring block system T equal to 2 pi root m by k. It is independent of G. Time period of a simple pendulum T equal to 2 pi root L by G. Acceleration due to gravity G equal to Gm by r square. In terms of density, it can be written as 4 by 3 pi G r rho. That implies G is proportional to r and rho. So when you take the ratio of accelerations due to gravity on planet and Earth, we get G planet equal to Ge. So the time period of simple pendulum is the same on planet as well as Earth. In the circuit, B1, B2 and B3 represent identical bulbs. Consider the case 1 with resistance R4, case 2 without resistance R4. R4 is comparable to resistance of the bulbs. Brightness of the bulb depends on power consumed by it. Power consumed is given by the formula I square R or V square by R. Here we will be using V square by R. First consider the case when R4 is included in the circuit. Since all the resistors are same, potential across B1 can be written as V1 equal to R by R plus R by 3 into V, which comes out to be 3 by 4 V. Potential across B2 and B3 and R4, since all of them are connected in parallel, will be 1 by 4 V. Now power consumed by bulb B1 is V1 square by R, that comes out to be 9V square by 16R. Similarly, power consumed by bulbs B2 and B3, V square by 16R. Now consider the circuit without resistance R4. Potential across B1 will be 2 by 3V. Potential across B2 and B3 will be 1 by 3V. So the power consumed by B1 comes out to be 4V square by 9R, and power consumed by B2, B3 comes out to be V square by 9R. From the above expressions we can conclude that B1 is the brightest in case 1, and in case 2 B2, B3 will become brighter and B1 will become dimmer than the case 1. Three identical resistors, each of resistance R, are connected in the following four configurations. Rank the arrangement in the order of their equivalent resistances from highest to lowest. First diagram, series combination, so effective resistance is 3R. Second diagram, parallel combination, so effective resistance is R by 3. Third diagram, a resistance is connected in series to the parallel combination of two resistors. So it is R equal to R plus R by 2, that is 3 by 2R. In the fourth diagram, first two resistors are in series, then the combination is connected in parallel to the third resistance. So the effective resistance comes out to be 2 by 3R. A positively charged insulator is brought in contact with an uncharged conductor. Then, as the charged object is placed in contact with an uncharged object, conduction of charges takes place. Charge flow takes place from a body at a high potential to a body at a low potential. So, some positive charge flows from charged insulator to uncharged conductor due to conduction process. Two infinite wires carrying identical currents are placed at positions A and C normal to the plane of the paper as shown in figure. The resultant magnetic field at point P on the perpendicular bisector is. Magnetic field lines around a current carrying conductor are in the form of concentric circles. Tangent to this circle gives the magnetic field direction at that point. So, fields due to wires A and B are equal in magnitude and perpendicular to each other at point P. The resultant is angular bisector, so the resultant field is horizontal, that is parallel to the line AC and is directed towards right. When an incandescent bulb is switched on and the outer glass bulb also gets heated up, this is due to. Let us see three processes of heat transfer. The conduction process, which requires a material medium, solid. Heat is transferred through the connectors to the glass bulb from the filament. Convection process of heat transfer also requires a material medium, but it may be a fluid. Heat is transferred through the inert gas, generally argon, filled in the bulb from the filament to the glass bulb. Radiation process of heat transfer does not require any medium. It is a heat transfer taking place through vacuum also, but it takes place preferably at very high temperatures. So when the filament is at very high temperature, radiation process of heat transfer also takes place. Ultimately, the correct option is A. We all know the sky appears to touch the ground at a distance. The distance at which we perceive the sky to touch the ground is called horizon. The reason for this perception is due to the fact that the earth is a sphere and not a flat surface. Which of these pictures below accurately depicts the horizon for a person standing on a high-rise building like Burj Khalifa in Dubai? Here, H represents height of the building and capital H represents horizon. See the diagrams carefully. As the person is standing on a building of height h and looks straight, he will be able to see up to a distance capital H, which is represented by the first diagram.